All right, let's start class, and today I'm going to focus on geometry. So I assume that you know how to plot a point in the XY coordinate system. For example, this is the coordinate system, right? Right, we already saw that. And if we have a bunch of points, for example, 0 and 0, and here's another point, 2 and 0, and 3 and 2, for example. I just sketch it, okay? So my question is, what is the volume of the, what is the area of this triangle, okay? Find the area of the triangle ABC. But this is a special triangle, so it's very easy to see, right? Yeah, you know, the area formula is the base times height, okay? Divided by 2, okay? So the area A is going to be half of the base. Base is 2 minus 0, right? It's 2. And the height is also 2. Look at that, right? Doesn't matter where it is. So the answer is 2 square units. That's easy. Okay, so you know the base, you know the height, you can easily find the area. But now I'm going to move the point to B a little bit. Okay, so this is the y-axis, this is x-axis. I still start from origin, right? This time I'm going to, here's 0, 0. That's going to be 3 and 2, and 3 and 1. Then connect that. So A, B, and C. Find the area of this triangle ABC.
A equals.
Yeah.
A equals 3. Yes, it does equal 3. I mean 1.5. Sorry. The height is 1. So area equals 1 times 3 divided by 1.5.
Yeah, 1.5. That's right.
I said 1.5.
So, you know, there are a couple ways to do this problem. If you already know the base, right? So the area is going to be, the base is going to be 1. The height actually is from here to here. It's a 3. So it's going to be 3 over 2. It's 1.5. That's a quick way. Another way you can solve this problem is the area of the larger triangle subtract the area of the small triangle. Okay, the area of the larger triangle is the height is going to be 2, the base is 3, minus the area of the smaller triangle under that. So the subtraction, the subtraction. This is a good idea. The subtraction gives you, this is a good idea. Gives you the area, the difference. Sure.
Oh yeah, I have understand.
Right. So what we did as the second method is take the difference of these two triangles. Okay, the one is from A to C. Then this may be called D. You know, ACD minus ABD. Okay, so that is actually the area of a triangle ADC minus the area of triangle ABC. No, ADB. Okay, so that's why you know this idea. The second idea is actually better for the other problems. Let's look at a little bit more general. Triangle. Okay, so here's A, here's a B, this is a C. It's a 0, 0. It's a 2 and a 1. Here's a 3 and a 2. For example, find the area of this triangle ABC.
Oh, isn't it the same thing?
Okay.
So why? You seriously have to do that. No,
No, it's a slight difference.
Is it the same question as the earlier one? Nope. No, it is the same.
Yeah, just step by step, I'll make it even more general. So there some students only get a 1. No, that's for different answer.
Oh, you put your buds.
Okay.
Good for you.
Hey, Joshua, put it away. Okay. So, how do you solve this problem?
It's 3. What Jasper said. Probably not. I say the correct answer, so a correct answer.
Okay, we can do it in the following way. We draw the line here, and this is a right triangle, and do the subtraction, right? And so the area of this triangle is going to be the area of the larger triangle minus the area of the small triangle and the area of the trapezoid. Okay, so from here to here, you know, this is going to be 2, right? It's 2, and here's a 1, and this is also 1. It's 1 from this 2. Okay, so now the area is going to be the area of the larger triangle, which the base is 3 times the height. Then you subtract the area of the small triangle, and this is the area of the small triangle, right? Then the area of the trapezoid, and the one side is 2, 1, the other side is 2, divided by 2 times the height of the trapezoid. All right, so that gives the answer. Here is going to be 3 minus 1 minus 3 over 2. Okay, it's going to be 2 minus, it's a 3 over 2. Okay, so we use a subtraction idea, right? There's the larger triangle, right? And you subtract the area of the triangle, smaller triangle, and the trapezoid from the larger triangle. Right. All right, got it? Did you get the idea? So now I'm going to ask you to do the next problem.
No.
What is the area of a triangle with vertices? Okay, 1 and 8, and 9 over 2, and 9 over 2, and 1 and 2.
Plus 1,8.
Yeah, I'm going to. Now that should be not that is not going to be complicated. I'm going to change the problem. This is a So let's try the 2 and the 4. Okay, I'm going to make it different. Yes, the last point is 2 and was called 2 and 4. All right.
Wait, I think it's the same. No, I need to plot it down.
Yeah, I'm going to plug it down. Then you work on that. Okay, 1, 2, 3, 4, 5, 6, 7, 8. That is the point A. It's 1 and 8. Let's use point B. 1, 2, 3, 4, 5, 6, 7, 8, 9.
The area is the area between 1, 8, 9, 2, and 2, 4.
And the other one is going to be 1 and 2, 4. 1, 2, 3, 4. Right? This is the C, and 2 and 4. So you get triangles like that. Right?
What happened to you?
Jasper?
I don't know.
All right, so figure it out. Okay.
We got 5. We're counting boxes. How do you make the box? I'm just gonna use that. Let's create our graph. We should have our graph. Probably stole something. Expose. Yeah, you can stop that. Okay. Okay. I say it's
Okay, so anyone get answer?
Nope. Almost.
David, Shen.
The answer is 16. Well, I got 12. I got 16. Is 12 correct? I got burnt chicken nugget. Is 12 correct? 16. No. I got it to buy stuff.
Okay, so look at this triangle. All right, and you have to draw some lines, right? And that is going to be you can also yeah. You can draw this line, right? So now you have the triangle, the larger triangle, then you have a one triangle, one trapezoid. So the area is going to be the area of the larger triangle. The base is from 1 to 9, so it's going to be 8. Okay, and the height is from 2 to 8, which is 6. That's the area of the larger triangle. Then you have to subtract the area of the trapezoid. The trapezoid, the base is going to be 6 here, and plus another one, and 4 minus 2, which is going to 2. And then times from 1 to 2 is going to be 1, okay, the height. Okay? Then you subtract the area of the triangle of this triangle under the shaded triangle. All right, so that means from 9 from 2 to 9 is 7, and the height is from 4 to 2. That's going to be 2. Okay, and divide by 2. Okay, that's it. So let's 24. Let's do the computation. Minus and 8 divided by 2 is 4. Minus 7. Okay, so 20 minus 7 is going to be 13. Why it's 16? I don't know why.
Oh, it's 16. Wait, no, it's 13. Wait, what?
Yeah, let's double check it. The trapezoid from 1 to 9 is a triangle. 网络通了。他没连上，我的学生都在网上。对啊。Okay. Any other answers? So 13, that's my computation. 8 times 6 divided by 2, that's triangles, you know, use a subtraction. This is the idea, okay? And anyone got 13?
And everyone is going to say, yes, I got 13. I got
Okay, let's redo the problem. I want to make sure half of the students can do the problem. Okay, so this time I'm going to just plot the points, and this is going to be 1 and 1. Okay, and then here is going to be 4 and 2, and then another point, and that's going to be 2 and 4. Okay, find the area of this triangle. Of this triangle A, B, C. Okay, I don't want to see you give me the answer. You got the idea. Use subtraction.
You have the idea. We're smart. Or are we? Dun, dun, dun. Smart at work. Okay. That was Apex Legends. I just got it today. I haven't got it. Ooh, but Apex, there's no phone. It's so better than your trashy game. I like it. I like the experience. Best how to do that sound. Ooh. I don't know how to do that. I like to try it. Okay. What? 3. It's not 3.
Anyone have answers?
6
Karen,
3.5.
Karen, John.
3.
3
burger. 2.5. 3. 2.5. 3. 2.5.
Kaden.
2.5.
3. Jasper.
What? What?
What's? Do you have a look?
No. Is it 2.5?
David. I'm calling your name. Okay, are you there?
Wait. Stop. Just trying to get in my thinking. Is it 2.5?
2.5. David said got 2.5 under my pressure. Okay, let's do it. All right. We're trying to use subtraction to solve the problem. I put it. There are many ways to do that. I put it into rectangular box. How about like that? Okay. I put it into rectangular box. This is the shared region, right?
Let's get it.
Okay. Then I'm going to mark each side. From 1 to 4, this side is 3. From 1 to 2, this side is 1. From 1 to 2, yeah. And from 2 to 4, this side is 2. No,
1.5.
Okay. From 2 to 4, this side is 2. Then from 1 to 4, this side is 3. Okay. So that's the picture.
It's 1.5.
And from 1 to 2, this side is 1. So the area of the shared region use a transect. Okay, first of all, 3 by 3. This is area of the square. Okay. Then subtract the area at the bottom. 1/2 of 3 times 1. Then subtract the other triangle. Subtract 3 times 1. Okay. So you will get 9 minus 3 over 2, 3 over 2, you get 3
It's not
minus 2. So 9 minus 5 is equal to 4.
Oh, it's 4?
It's a 4. Just look at subtraction. Anyone got 4?
Wait, it's 4? I got 3. I got 2. I got 2.
Just look at subtraction, right? First of all, you look at the square. This is square. 3 by 3 is 9.
Hey, you forgot a number.
Right?
You forgot how to calculate. You missed the number.
And then
No, you missed the half of 3.
yes, this is half of 3, this is half of 3, so total is 3.
Oh!
Alright, then minus. Okay, so the triangle at the bottom is 3 times 1 divided by 2. Then other one, the triangle on the left hand side is 3 times 1 divided by 2. And 2 by 2. Yes. Got it? Okay. I really want you to pass this part. One more problem. Promise me. Do it. Like if you understand how to do it, just use subtraction. You subtract the area of the triangle surrounding it. Okay. Then from whatever rectangle, cover this triangle. Cover this triangle. Okay. One more problem. Josh, pay attention. Okay, so we are going to have, right? So this is the 1 and the 2, and this is going to be -3 and -1, and this is going to be 2, -3.
That's my workspace.
Okay, so it's A, B, and C. Find the area of this triangle.
Ooh. Bang, bang, bang. Now that's what I call a lot of damage. Fire, you're serious. No, fire didn't miss.
Yeah, use a subtraction to solve the problem. Yeah, put it in the larger rectangle.
I just say never miss. That ain't what. Thought I was, but I no. 1, 2, 3, 4, 5 times 1 plus 2.5. Then 1, 2, 3, 4. What is your problem? 1, everything. 4. 1, 2, the big box. 1, 2, 3, 5. Okay, this is done now. 9. I got 16. 16.
16?
Not so fast. Not so fast, big boy.
Are you sure?
Yes, I am sure.
Alright, so the best way to do is to draw a rectangular box that cover it, right? So you have this triangle, you have this triangle, you have this triangle. Okay, so find the area of this rectangle, then subtract the area of 3 triangles surround it. Okay, so let's figure it out. From -3 to 2 is 5, and from -3 to 2 is also 5. It's a square, right? And then from here, -3 to +1, it's going to be 4. And from 1 to 2, here's the 1. And then from -1 to +2 is 3. From -1 to -3 is 2. So total is 5. That's correct. So each side you mark it. Right?
It's 11.5.
Right, so 11.5 or 12.5? 12. 13 point. 11.5? How I got 6.5?
Yeah, how do you get 6.5? Tobias said it's 11.5.
Tobias got 11.5.
Tobias, I don't think listening to Jess was a good idea. Because you all are dumb. No. Yeah, you're right.
Any different answers? Any different answers? Okay.
Fish. I'm not a fish. I'm like 16. I said 11.5. I said 16. I said 11.5. 16. You can't talk. Yes, I can.
Oh yeah, let's do it. So the area is going to be the area of the square minus the area at the bottom. It's going to be 2 times 5 minus the area of other side on the right hand side minus the area of the triangle at the top. Okay. So what do you get? 25 minus 5 minus 5 or 2 minus 6. So 25 minus 5, 20. 20 minus 6, 14. 14 minus 5 or 2 is going to be 11.5.
You said 16.
Okay. All right. So yeah, let's stop here. Assuming everybody understand, and then you need to practice.
Yeah.
Okay. So our next problem about the triangle. Okay, the triangle. The triangle has 3 angles. What is the sum of the 3 angles?
180.
Everybody know that?
Yes. No, it's not. It's in 5th grade. It's in 5th grade math. It is.
Okay, 180.
So I learned it like I had to learn it.
Here's a question. If the triangle is put on the basketball, and do you think the sum of 3 angles will be still 180 degrees?
What?
If the triangle is on the basketball on the basketball.
If a triangle is on a basketball, it will still be 180 degrees.
Yeah.
Yes. Yes. Oh, wait.
What kind of
in
ball?
A basketball?
What kind of ball? No.
A basketball. He just said.
Well, on a ball.
Yeah, actually the sum is larger than the sum of 3 angles larger than 100 degree. Okay, but right now I can talk about
But
this.
it'll still be 180, right?
No, well, larger than 180.
Wait, does the ball like warp it or something? Warp it? Yeah.
No, I'm not going to talk about this here. All right, so here's the first question. I draw a triangle here. I know this is a 30 degree. I know this is going to be 110 degree. Can you find this angle?
40 degrees. So obvious. Nope.
This is obviously larger than 90 degree.
Oh, it's 140 degrees.
Yes, 140.
Why?
Hey, stop copying my answer.
Because of the 180 degree angle, you find that the inner angle is 40 degrees.
Oh,
Then you subtract the 180 degrees from 40, and that's 140.
And you're still trash it.
No, I'm not.
I've got road spikes too.
140 degrees.
140? Are you sure?
Yeah, 140 degrees.
Probably yes. I will lose your.
You're so dirty, Mike.
I will probably.
Okay, yes, 140 degree. Okay, so first of all, this angle is going to be 180 degree minus 110 degree minus 30 degree, which is going to be 40 degree. Okay. Okay, but the sum of 2 angles must be, 180 degrees. So this implies 40 degree plus alpha should be 180 degree. So alpha should be equal to 140 degree. Okay.
It fits.
Long or short?
It is smooth.
How or
How
short?
is this?
Long or short?
All right. So our next question is,
It's
this is an isosceles triangle,
Oh, you're in high school?
and isosceles triangle, the vertex, the angle at the vertex The angle at the vertex
Carry or plane?
is twice the base angle. Okay, what is the base angle? What is the measurement of the base angle?
In and out further. Yes. It's actually
45 degrees.
It's only a
It's
single.
not the hard diameter.
Twice the base.
Okay, so question. This is can you do that?
2 days in 2 years.
Okay, so here's let's say beta. This is alpha. This is alpha. So if beta equals if the angle is twice as the base angle to alpha, what is alpha? Roughly speaking.
Alpha?
Yeah, the angle at the vertex on the top is twice the base angle.
It's alpha is 45. 480 divided by 8. 45. Wait, but that's possible. Okay. How? Look it up, please.
Jasper, I'm waiting for your answer. Hurry up.
I'm thinking it's 45. It's Oh, I know. That equals 2. I don't know. I slipped on a banana peel.
You did?
No.
I don't know. He doesn't know what happened.
45. No. Excellent.
I used that.
Okay.
No,
It's a medical condition.
Yeah, I used it.
It doesn't go away.
Okay, let's do the problem. How many of you got 45? All right, let's do the problem. We know that beta is 2 alpha, right? So you have a isosceles triangle is, 2 base angles are the same. So this is alpha, that is a 2 alpha, right? So 2 alpha plus alpha is going to be 180 degrees. So alpha equals 180 degrees divided by 4.
I don't think we would learn about alpha
Right.
in 6th grade.
So then you have to do 4D, right?
Nerd.
Yeah, 45 degrees. So that's going to be 45 degrees. Okay?
It was like nerds. It was in my history book. You're just jealous that we're smarter than you. You're just jealous.
All right. I have another question. So I have a triangle. So this is the alpha, this is the beta, this is the gamma. Okay? Alpha ratio beta to gamma is going to be 1 to 2 to 3.
Gamma, I'm in honors math and ELA.
Find the alpha.
Nerd.
So the ratio alpha to beta to gamma is going to be 1 to 2 to 3. All right, got it? Do you understand the question? Can you determine the smallest angle?
Alpha. Wait, when you're precise, if you're in honors.
Joshua.
Now? Alpha. Beta. 30. 30. It's 735 if you know how to read.
Maybe do you know how to read?
Wait, equals 1, what, 2, what, 3? 1
Ratio, the ratio.
Then it's 1. Oh, find that. Okay.
So beta is double the alpha,
30,
right?
30,
Gamma is 3 times alpha. So basically, beta is going to be 2 alpha, and the gamma is going to be 3 alpha. So add them together, add them together, alpha plus beta plus gamma is going to be alpha plus 2 alpha plus 3 alpha, which is 6 alpha is going to be 180 degrees. Okay? So alpha is going to be 30 degrees.
Ew. Well, I used to go there. That's so trash. Yes, you still think. Yes, you still think.
And this is small triangle, but this is just about triangle. How about the n polygon? Okay, if it's n polygon, then the formula will be different. Okay, if this is called n polygon, it has many sides, n sides, right?
Charlie Coffee told one.
Joshua,
Mm-hmm.
shut up. Okay, that's n polygon. So you have n side. Then it says that the sum of interior angles is going to be n minus 2 times 100 degrees. It's more general than the triangle. Okay, have you heard about that? So the special case is an arbitrary convex body like that. Okay, so this is alpha, this is alpha 1, alpha 2, alpha 3, alpha 4. So the sum is going to be n minus 2 times 180 degrees. That's 360 degrees. Okay, so the sum of 4 interior angles is going to be 360 degrees. Okay.
Question.
Yes.
For the n if n is the polygon, how do you do polygon when n is 2?
Oh, n is not for polygon. It's called n polygon. This is called n polygon, means a polygon with n sides. Okay, a polygon with n sides called n polygon. Right? It has n sides. So then you have n interior angles, which is alpha 1 plus alpha 2, alpha 3, all the way to n. This is going to be 1 minus 2 times 180 degrees. Right. So in particular, when it has 4 sides, then 4 minus 2 times 180 degrees, 360 degrees. Okay. So now let's do the next problem. Joshua, pay attention.
Okay.
Next problem. Okay. What is an exterior angle
One exterior
of a regular 9-sided polygon?
exterior angles?
Yeah. The difference between exterior angle and interior angle is the sum is going to be 360 degrees, right? So this is the regular 9 polygon. 1, 2, 3, 4, 5, 6, 7, 8. Oh, come on, just 8.
Yeah, it seems weird because like a 9-sided wouldn't have perfect sides.
I know that you can get perfect side. 1, 2, 3, 4, 5, 6, 7, 8, 9. I just drew 9 sides. Okay.
That won't work. That's still 8.
No, this is 9 polygon, but if all the sides are equal, called a regular polygon, 9-sided polygon. So what is the exterior angle? What is the exterior angle? What is this beta? That's the exterior angle.
Oh.
And then what is the interior angle?
Are all the angles the same?
Yeah, interior angle.
The interior angle is the same.
1, 2, 3, 4, 5, 6, 7, 8, 9.
220 degrees. 220. Wow! Goodness. Stop! It's 220.
Huh?
It's 220 degrees. Hey, I said that. I got two. What's 360 times what?
too much noise.
Stop! This is your work, you say? What's 360 times 9? 360?
Yeah. 1, 2, 3, 0.
Sin 32 over 15 equals sin A over 19. I'm a nerd. I'm Crystal.
Okay, so it has 9 sides, all the angles the same. So 9 alpha equals 180 degree, right? No, 180 degree n minus 2 times, which is 7, suppose. 9 minus 2. So 9 alpha equals 7 times 100 degrees. So alpha equals 7 times 100 degrees divided by 9. So that's going to be 20 times 7, right? 20 times 7, 140 degrees. So alpha is 140 degrees, but that is the alpha. But you have to find the beta. Beta is given 360 degrees minus alpha. Okay, 220 degrees is going to be the answer. Okay. All right, my question is,
Oh, no.
what is the sum of the exterior angle?
So we're gonna do 22.
1,980.
8 equals 47.80. I solved it. Okay. A equals 47.2. Out.
Yeah.
Backside. Yeah. Yeah, but still. Look back.
Okay. Well, okay. Here, let's correct our definition of the exterior angle. All right. So the angle, exterior angle, by definition, okay, beta is 220 degree, okay? Beta is 220 degree, but that's not the exterior angle. That's what is, here's the definition of exterior angle, okay? So you have if you have a hexagon, right? If you rotate the counterclockwise using that, okay? And this is the angle is called the interior angle.
Yes.
No question.
So exterior angle.
Exterior angle, you have to extend it like this line and counterclockwise. That's called the exterior angle. Okay, that's called the theta. So this is called the exterior angle. Okay. So this is called the exterior angle. Got it?
This guy has some serious.
Yeah, this is called exterior angle. So now that the exterior angle, actually you have to, in our problem here is theta, you have to do the subtraction, you know, and the whole beta minus 180 degree, which is 220 degree minus 180 degree, that is going to be 40 degrees. That's called exterior angle. Okay?
What time is it? 7:45.
Time for you to get a watch.
All right, so that is exterior angle. Yeah, that's called exterior angle. Okay, so the sum of exterior angle is going to be 4 times 9 is 360 degrees. Okay? Yes. And let's do one more problem. Okay.
I'm sorry.
Yeah. So what is the sum
I knew it.
of the exterior angle of this triangle?
This is wrong.
Of the three exterior angle. Okay. What is the sum of the three exterior angles? Right.
I need some time.
What is the sum of exterior angle?
180. Exterior.
Yeah, what's the definition of exterior angle? We rotate counterclockwise, extend. This is the theta 1. Then you come to here. That's the theta 2, and that's going to be theta 3. Okay. So theta 1 plus theta 2 plus theta 3 equals what?
900 degrees. Yeah. He barely used them though. Is it 900 degrees? Who is that?
That guy.
David.
What is it,
Shen?
Why does he have his camera on?
All right. So,
He lives in my neighborhood.
Why does he just come here?
okay, David, what's your answer? David, what's your answer?
He just like lives in
Burnt chicken nuggets.
Okay,
New Jersey? Yeah. I have to drive 3 hours every week.
180 degree.
Not 3 hours.
Jasper.
I got 900 degrees for the exterior.
And then
Because I took the sum of the interior degrees, 180, and then
I think it's going to be. I think it's going to be 360 degrees.
no.
You do agree, disagree? Let's call this alpha 1, okay? Alpha 2, alpha 3. So theta is going to be 180 degree minus alpha 1, right? Beta is going to be 180 degree minus alpha 2. Theta 2. Theta 3 is going to be 180 degree minus alpha 3. So total, you have a 3 times 100 degree minus alpha 1 minus alpha 2 minus alpha 3. But the sum of 3 angles is going to be 180 degree. So that's why we twice of 180 degree, which is still 360 degree. Okay? Got it?
Yes.
Okay. So you know that if I give you a rectangular box, right? For the rectangular box, what is the sum of the 4 exterior angles? Because they are all 90 degree, right? Exterior angles are all 90 degree. So they're going to be 4 times 90 degree. It's still 360 degree. Got it? So look at every time the sum of the exterior angles are the same, always 360 degree. Okay, no matter how many sides there. All right, now this is about degree. Let's look at this as a type of problem. A rectangle was non-congruent at the junction sides, okay, and a square share a side of a length. This is a rectangle, okay.
No, not at all.
So no congruent at junction sides. So a square and a square that share one side of 6. So this is a square. Here's a rectangle. This is the square. Okay? And the perimeter of the rectangle is 40. What is the ratio of the area of the square to the area of the rectangle? Okay. So if the perimeter of the rectangle is 40, okay? And what is the ratio of the area? Okay. So we have one rectangle, and this is the width, this is the length, and this is W, right? L and the W. So I know L is not equal to W, so we assume that. Okay. Can you solve the problem? Find the ratio of the area of the square to the area of the rectangle. Joshua, we'll call this problem.
It's 40.
And then what is the area ratio of the area of the square to the rectangle?
Yeah, this is square and a rectangle share the one side of the length of 6. Come on, that's not
I know this. 32. 4 times 6.
So first of all, you get
24 to 36.
Yeah, first of all, you double, you get 6, right? And then
12 to 18.
the perimeter of rectangle is going to 2L plus 2W is going to be 40, right? Okay, so then you find the L, right? L is going to be 40 is 20 minus W is going to be 14. Okay, so L is 14, then W is 6, then the ratio of the square is going to be, the ratio is going to be 6 square, okay, divided by L times W, right? L times W is going to be 6 times 14. So it's 6 over 14, right? How come you get 13? Right? It's going to be 3 over 7. That's what I get. 56. Right? Come on, did nobody give me 3 over 7?
3 over 7. 3 to 7.
Right, another problem is the area of rectangle is 40 square units. The length of the rectangle is 12 units. What is the width? Okay, I know that the area is going to be 40 square units, and the length is going to be 12 units. Find the find the diagonal, the length of the diagonal.
Oh, I don't want to do this at all now.
Okay, this is a rectangle. This is a rectangle.
40 over 12 square.
It's like 3 something.
Approximately 3. About 3.
We assume that you know the Pythagorean theory, right?
Yeah. A squared plus b squared is 50. So it's about 9. It's about 9.
Come on. Quick.
Done.
You done? What is the answer?
9.
9?
About 9.
What do we cannot say about?
Well,
Give me the exact value.
3.33333.
Give me fraction if it's a fraction. Just
10
put
thirds. 10 over 3.
That's not the exact answer.
Okay.
okay, write it down.
26 over 3.
Square root of the difference is 4 over
What?
44.
Don't talk to me right now. I'm going to try my move.
Totally, guys. That's
682 over 9.
Hmm?
682 over 9.
You don't have a radical?
nope.
Oh, square root.
Square root of
Square root of 682 over 9. Did you guys say anything? Oh,
All right, so this is the width,
no.
this is the length, right? That's a 40, right? L times W equals 40. L plus W, we don't know, right? But we already know the length, okay? So the length is, this is gonna be 12. So then you can get W. W is a 40 over 12, right? Yeah. So you can simplify it. It's divided by 4. It's 10. It's a 3, right? 4 times 3 and 4 times 10. Okay. So the length of the diagonal D square equals L square plus W square. So L square, L is 12 square. W is 3 over 10 square. It is simplifying this. Okay. And let's try. Okay. 12 is 3 times 4. You know, you factored it out. Okay. You can also take 3 out. 3 square out. Then you have a 12 square times 3 square plus 10 square. I'm going to try to figure it out. Okay. Well, this is a complicated number, and you can, if it's an even number, right? You know, you can take 2 out. 2 times 6 square, and 2 times 5 square, right? 2 times 5. So actually, you can get 2 out. Then you have a 6 square times 3 square plus 5 square. Let's compute it. We have to do this computation. Okay, 36 times 9.
Already?
So that's be 32. Okay, and the 25. It's 9. 4. 349. 349. That's what I got. Okay? Yeah, then D is going to be square root of 349. Okay? So that's it. We're done with today's class. And I hope you enjoy the spring break.